Hello, I am Shushavan Ray, working as an assistant professor in EC department of SBSD. Uh, Today, I want to discuss uh, the internal architecture of Intel 8085 microprocessor. I have already discussed some basic features of Intel 8085 microprocessor and some basic uh, units of 8085 such as accumulator, program counter, stack pointer, some general purpose registers, instruction register, temporary registers, etc. And now today, before going to the next sections, I want to say that there are some units which I have already discussed in previous class. These are basically called the control unit, data control unit, and another one is which I have already discussed. This is called the buses. Buses are basically classified into three types: address bus, data bus, and control bus. So data bus means through which the data in binary form could be transferred in between microprocessor to any other external devices. It may be our device or others. In case of 8085, always remember the data bus is 8-bit and the address bus is 16 bits. So that is why this is called 8-bit processor. So what is address bus? So if we focus on this particular diagram, we can see 8085 has 16-bit address bus and are generally identified as A0 to A15. Uh, and there is a higher order address line such as from A8 to A15 are unidirectional, and the lower order address lines which has been segregated from A0 to A7, and they are basically multiplexed with time shared mode with 8 data bus, 8-bit data bus, for example D0 to D7. So finally we can say that the lower order uh, address data lines are basically AD0 to AD7. Okay. The Intel 8085 microprocessor contains the flip-flop to serve as status flags. So flip-flops are set or reset according to their conditions. Suppose 00, 01, 10, several kind of conditions could be arised uh, to set or reset the flip-flops. There are 5 status flags of Intel 8085 are. One is called carry flag. So before describing the flag register, here I want to say about the status pins. So here you can see in this particular table, there are two kind of status signals are available in Intel 8085 processor. One is S1, another one is S0, and their operations could be written over there. So if we apply 00, that means both status signals are in reset condition. In that case, the processor is in hold state. When it will be 01, it will be in write state. When it will be 10, the processor will able to read, and when it will be 11, then this is called fetch conditions, or the operations will be fetch operations. Okay. So now, what is serial IO control? So it has two control signal. One is called SID, another one is called SOD. Serial input data and serial output data. And another very vital unit or the important unit which is available in 8085, this unit is called timing and control unit. So if we go to the main diagram, here you can see this particular segment is called the timing and control unit. There are several kind of signals are over there. One is called control signals, data signals, DMA, clock, etc. Timing and control unit, there are basically three control signals. One is ALE, read and write. Okay, read is active low and write is also active low. And IOs or M, actually M bar, input, output and memory, and S0 and S1. These are called the status signal. I have already told. So ALE is used for provide control signal to synchronize the components of microprocessor and timing for instruction to perform the entire task. And read write signals are used to indicate whether the operation is reading mode or the data could be data from the memory or writing the data into the memory according to the basic needs. And IO/M bar, which is active low, is used to indicate whether the operation is belongs to the memory related or the peripheral related. So this is the register organizations which I have discussed in previous slides. Here you can see accumulator, which is also 8-bit register, and there is a flag register which is also 8-bit, and there are some general purpose and special purpose registers B, C, D, E, H, and stack pointer, program counter. All of these are the 16-bit registers among all. Okay. So accumulator, what is accumulator? Accumulator is a 8-bit register which is also the part of the CPU, ALU. This register is used to store 8-bit data and to perform some arithmetic and logical operation. Next, flag register. The flag register, the ALU basically includes 5 flip-flops which are set or reset after the completing the operations. There are 5 flags are present. One is called zero flag, then carry flag, sign flag, parity and auxiliary carry flags. And their bit positions in the flag registers are shown in next slide. So this is the bit positions of flag registers: D0, D1, D2, D3, D4, D5, D6, D7. This is also a bit register, but according to the bit positions, if we observe this diagram carefully, we can see at bit 0 or the D0 positions, this is for carry status. This is indicating the carry status. Then the second bit D0, D1, D2, bit position 3 or D2, this is called parity. Then D3 is undefined and D4 is known as auxiliary carry AC. D5 is also undefined and D6 is zero flag. D6 is for zero flag and D7 is for sign flag. So what is sign flag? Sign flag means after executions of any arithmetical or logical operations, if the result is positive, then it will be set to 0. Okay. And when the sign of the sign flag S is set to 1 if the result of an arithmetical or logical operation is negative. Okay. Next, zero flag. The zero flag is set to 1 if the result of ALU operation is 0. Otherwise, it is in reset condition. Next, auxiliary carry. Auxiliary carry is a very one of the very important flag bit positions among other flag. The auxiliary carry holds carry out of the bit number 3 to the bit number 4. When there will be carry generated in between D3 or D4, then AC or the auxiliary carry is set to 1, otherwise it is in reset condition. Next, parity flag. The parity status flag P is set to 1 if the result of the arithmetical or logical operations contains even number 1. Okay, whenever the output of the arithmetical and logical operations could be representing even number of 1, then parity flag is set to 1, otherwise it is in reset conditions. Next, carry flag. Whenever we are doing some ALU operations, in that case, if there is a carry is produced, then the status of the carry flag is 1, and whenever there will be no carry, then the status of the carry flag will be 0. So now, if we observe the architectural view of Intel 8085, which I have already discussed, here we can see there is a stack pointer and program counter. So what is the basic meaning of program counter? Okay, so program counter, this is a 16-bit register sequence. It is a memory pointer. That means if we want to point a particular memory location, then the PC status will be 1. Okay, that means it is in inactive mode. Okay, so that means the memory locations have 16-bit address, and it is also a 16-bit register. Okay, and it is always hold the next memory locations by increment by 1. Okay, next, stack pointer. This is stack means, which I have already discussed. Stack is a one kind of storage container. Okay, where we can from where we can retrieve or we can store data in a particular from the particular register into the arbitrary address locations. This is also 16-bit registers used as a memory pointer, and there is a particular technique is used in a stack. This is called LIFO technique, last in first out. The beginning of the stack is defined by loading a 16-bit address in the stack pointer. Next, temporary register is used to hold the data during the ALU operations, and instruction registers is basically used to fetching an opcode from the particular memory locations, and it is always loaded into the instruction register. So after that, the instructions after fetching the instruction, it will be executed or decoded by the decoder. Thank you.